Hey, welcome to the channel. Here we talk about networking and cybersecurity. My name is Samuel Barlis, and today we're going to be talking about TCP sessions and stateful firewalls. Before we get started, of course, I just want to let you know any opinions expressed in this video are my own and do not represent any past, present, or future employers. So let's go ahead and get started here. So before we start talking about TCP sessions and digging into the nitty-gritty, I want to kind of give us an overview of where we are in terms of the OSI model. Now, some people will say, oh, the OSI model really, when we're talking the real world, we're talking a TCP model. I get that. But for the sake of this discussion, it doesn't really matter, and we will the OSI model. Hopefully you guys can see this all right. So really, layers 1 through 5, these are data. We're not worried about that really from a networking perspective. So going kind of from the bottom up here, we have our physical layer. And hopefully this is familiar to you guys, the data link layer. The network layer. I do not remember everything all the time, so forgive me there. And the transport layer is what we're talking about today. Hopefully you can see that all right. So when we go into the physical layer, we're talking about physical medium. We're talking about maybe copper or fiber. Data link layer, we're talking about the Ethernet protocol. Net, so maybe this is switches, MAC address tables, that sort of thing. Network layer, we're talking about IP. Maybe we're talking about routers or layer 3 switches. We're talking about IP addresses, whether it's IPv4 or 6. V6. On the transport layer, here we're talking about mostly TCP or UDP. Now there are some other ones that we can use. Those are generally niche use cases. We're usually going to be focused on TCP or UDP here at the transport layer. What we're focused on is, this is kind of all your hardcore networking. This is going to be, allowing us to transport our data in a way that makes sense for our application. So really, I want to talk about datagrams as well, because those are going to be important for our verbiage that we're going to use to determine how we're going to talk about these different kind of situations that the data is going to be in, depending on what layer we're talking about. Layer 2, we're talking about frames. Layer 3, we're talking about packets. Layer 4, we're talking about segments. Okay, so if you hear that word as I'm going on later, segments, that's defining what our data looks like at layer 4 with our layer 4 headers on it. Now, of course, in the real world, that segment would get encapsulated by a packet header and become a packet. It would be encapsulated by a frame header and become a frame, or an Ethernet header to become a frame, however you want to look at it. So, but keep in mind, again, for terminology and verbiage, we are calling these segments. So I want to get a little bit into TCP versus UDP here. And to do that, I want to start with a meme, because I feel like this really helps a lot of my students remember these things. I've had a few students come to me in the past and go, when I was sitting there, I was taking my test, I remembered that stupid meme that you showed, and it really just made a difference. So I'm going to show you this meme to hopefully give you a brief overview of TCP versus UDP. So TCP is very reliability driven. It's very specific. It's very focused. Whereas UDP is just kind of best effort, right? It's going to be just kind of, shove the traffic in the right direction and hope that it gets there. Whereas TCP is going to be very, very specific in how it handles things. So, when we look at TCP versus UDP, I'm going to pick on a few different metrics here, TCP and UDP. So TCP is going to be slow, UDP is going to be fast. So this is beneficial in UDP's case for voice or live video, because we need it to be very fast. TCP is going to be reliable. UDP is unreliable. So in TCP's case, its reliability is going to be helpful for stuff like maybe a database entry, right? Maybe we're loading a web page. Those things, we need all the data. We need to make sure we have it all. That reliability is going to be important there. Another thing that I want to talk about is when we talk about where we're deciding how large our segments are going to be, actually differs between TCP and UDP. And this is something that I find particularly interesting. TCP is going to use sliding windows, if you've heard of those. That's a fun topic. I'm not going to get into it for the sake of time. But UDP does not. So it actually lets the app decide. So the application developer is going to actually have some leeway there, and they're going to be able to decide how big or how small those UDP segments are going to be. Whereas with TCP, TCP is going to define how big the segments are, and is going to break up the data as it sees fit with TCP sliding windows. So jumping on from there, we're really talking about, okay, so we're going to kind of ignore UDP for the rest of the video for the most part, because it doesn't have sessions. UDP is sessionless, it's connectionless, but TCP is connection oriented. Or, we could say session based. So, when we talk about TCP, we're really focusing on this aspect of TCP that creates our reliability, is that session, right? So the idea of sessions is we're going to have some sort of establishing. Think of it like a conversation. So we're going to establish a conversation. So maybe I'll walk up to someone and I'll say, "Hi, my name is Samuel." Maybe I'll shake their hand. Maybe not in today's COVID world. But maybe I'll introduce myself, right? And I'll start that conversation. That would be our SYN message in TCP. And then they will go, "Oh, well, hi, Samuel. I am," and I'm going to pick on Kevin. Wore this for you, Kevin. They're going to respond back with, "Hi, I'm Kevin." That's our SYN ACK. So they are going to acknowledge that I introduced myself, and they're also going to introduce themselves. And then maybe I'll wrap it up with saying, "Oh, hey, nice to meet you, Kevin." I will acknowledge that we met. That is going to start our conversation as human beings. Now, it might not be so rugged with human beings, but with computers, it's very rugged and consistent, right? So we need a system in order to do that. Again, different cultures and stuff, this may vary a little bit, but in TCP, right, this is kind of the structure we're given. So these three actions here, 1, 2, 3, are what we call the TCP three-way handshake. And my penmanship is awful. But when we're talking about a TCP three-way handshake, I love to use this meme with Obama, Justin Trudeau, and whoever that guy is on the left. I don't know if you know who he is. Maybe shoot him out in the comments. He must be important because he's standing next to these two guys. But anyway, the three-way handshake is how we establish our session in TCP. So once we establish that connection, it's really a two-way conversation. So we don't necessarily, just have one person doing all the talking. Like this YouTube video, for example, I'm talking to you. This is really more like a multicast message. TCP, we're talking unicast, right? So it's going to be one-to-one. We're going to have back and forth communication. So either side can actually send data, whether it's the client or the server. They don't necessarily have to be one way. It could be. We could only send data one way, but typically you'll have data sent both ways. Actual data, not TCP messages. TCP messages have to go both ways because of those acknowledgments, right? So whereas UDP doesn't, right? Because we don't have to have those. So we have to actually have a separate ACK number for each way or direction. So that being said, when we're sending traffic this way, maybe we're sending 1 through 1024, then we'll send back an ACK, and we'll have the next number here. So really think of it again in that human conversation. When I go and I talk to somebody, maybe I'm talking to Kevin, which I'll pick on again. Hey Kevin, how you doing? And he goes, I'm doing great, but I'm really excited for the weekend. And so what I'm going to do next is I'm going to ask him what's next, right? I'm going to say, oh, hey, that's cool. You're excited for the weekend. What are you doing this weekend, right? I'm not going to go, oh, hey, cool, you're excited for the weekend, and then stop talking. If I want to do that, then I would have our way of ending the TCP session, which would be kind of the replacement of this, but instead of doing the sin, ac, we would do fin, ac, and ac, right? So we would finish instead of synchronize at the beginning of a session, we would finish the session. So we're asking for the next thing, right? So keep that in mind. The numbers are going to go up by 1 so that we're asking for the next thing. It's what we're asking for. It's not what we actually received, which can be kind of confusing when you're getting into this and learning about this. The other thing I want to mention is these ACK messages. When we're talking about once the session is established, these ACK messages may be delayed by a fraction of a second. I think the default is like 200 milliseconds or something like that. And really the hope is that we can wait for actual data to be going that same direction, and we could just add that flag in. So when we're talking about these messages, these sin, ac, fin, all of these are really just flags in our TCP header. So we already have that space designated for those flags in binary. So those binary bits are already going to be dedicated to those functions. So we're not going to add any length to the total bits that we're sending across the internet, whether these bits are on or off. They're not going to make it any more efficient or not. So we really want to wait until there's an opportunity to just kind of like tag along, for example, and not have to send a whole nother segment to include just that acknowledgement. So all that being said, I really want to take this home and hopefully, you're probably sitting there and you're thinking, Samuel, this is all great and this is cool information and blah, 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 but why does this matter? Maybe you're studying this just to take a test. Maybe you're going, okay, well, I get this. I'm going to memorize a bunch of stuff. I'm going to remember it. I'm going to, constantly remind myself, hey, I need to remember TCP sessions through a handshake, what that means. But you're going like, but once I take the test, it's over. I have no use for this information. I don't understand how this is useful in the real world. I'm just thinking about this for the purposes of achieving a specific goal of taking a test. And the goal of that test is maybe to get a job, maybe to get a promotion. And that's it. So how is this going to help you in the real world? And that's when we start talking about stateful firewalls. So when we're talking about stateful firewalls, really the important thing that we're going to have here that's differentiating them from the classic routers that we've used in the past is they're going to recognize our TCP session starts and ends. I'll just put sessions. So it's going to actually, because it's predictable, right? And we can see this from a firewall perspective. We can see when the connection is established. We can see when it's finished. Okay, so we can recognize those TCP sessions. Now this allows us to add our sessions to a table or a database to essentially keep track of them, right? So now we're keeping track of our sessions. So now we can allow return traffic just for those specific sessions, So say we have a firewall here. I'm going to draw a firewall. And we have some sort of server or service on this side, and we have a client on this side. So the client's going to send a message. Let's just say it's HTTPS, right? And so it's going to send that HTTPS message across the firewall. So we need to make a rule that allows HTTPS out, right? And traditional thinking would tell you that you need to accept HTTPS traffic going back through because you need to be able to respond to that, right? Because the server is going to respond back to the client. Well, that was the case with routers that are not stateful and don't have these stateful database tables. We can keep track of the states of the sessions, really. But with the session-based firewall or a stateful firewall, we can actually keep track of that. And what we're doing is we're keeping track of the socket. The socket is the IP and the TCP port. Losing my words there. So it's a combination of the IP and port, so that we know that this computer is going out on port 443 for HTTPS. So we're expecting a response on port 443 HTTPS. So we have all this in our state database or our session table. And so we're able to keep track of that information and recognize if we're supposed to get a response. So what does this do? We only allow the traffic for valid sessions, which is extremely important because anytime you have someone who is maybe trying to use a malicious tactic to send a reply message without a session, we can actually combat that with a stateful firewall. So the other thing that I really want to talk about here is logging. So with a stateful firewall, logging can be a little more complicated because we come to the question of, are we logging packets or are we logging sessions? So if we're logging just packets, then we'll have a lot more logs. And we're going to have to correlate those in some manual fashion. Now, maybe we could do it in a logging engine. Maybe we could do it in a SIM platform or something like that. Or we can do it kind of manually, right, with our brains. We can go and look at 100 different messages and go, oh, okay, this is all one session. Now, if we log by session, we actually just see one session, right? There was one connection. They sent, maybe there's, a data point says they sent 100 messages. Or only have one log to look at. This makes it a lot easier for human beings to read logs because you have a lot less going on and being distracting there. The other thing is when we're talking about maybe logging per packet instead of logging per session, there's a few caveats there. You may have more resource usage, especially in RAM. You may have more space taken up on your hard disks that you're logging to, whether that be a remote logging or onboard logging on your stateful firewall. And it may also, of course, it's going to be doing a lot more reads and writes, right? Because it's going to be logging maybe 100 packets instead of just one session in that table. So you may see some degraded performance when you're actually going to look at logs as well, because it's having to look up 10 times as many logs as you would otherwise because of that. Now, that being said, I know there are some firewalls where you can change your type of logging. And there's also settings in firewalls where you can turn stateful firewalling off if for some reason that's a problem. Now, that's a very niche use case. It's typically recommended against because, again, it's going to open that kind of security hole here in terms of making sure that those sessions are actually valid. So with that, hopefully I've given you some information on TCP sessions that's valuable to you. And I've also related that to a real world scenario where maybe you can understand stateful firewalls a little bit better. One of the pain points I had when I was on the operations side of the house was I had vendors come in and they say, we need all the ports open all the time everywhere. And I was like, no, that's obviously not what we're going to have to open. So what do you really need open? And they would, finally come up with a list of ports. Maybe they'd go to developers or something. They'd go, oh, we need port 876543. And it was like, okay, well, we'll open that port. I was like, well, what direction do you need that in? Like, where do you need that to go from and to? Do you need to go from the clients to the server, from the server to the clients? A lot of times we get a list of 4 or 5 ports. And a lot of times they didn't know. These implementation engineers, they didn't know. A lot of times I would guess that they didn't deal with someone who had really strict firewall rules very often. And so it wasn't something top of mind for them. And so they would say both. We need it to go both directions, obviously. Duh, like it needs to have a response. No, with the state database, with our session table, we can actually allow it the direction it's starting. And then that return traffic is in that table. So we can refer to that table instead of the firewall policies to allow that return traffic. One last thing before I close, I just want to give you a little extra tidbit of information. If we're ever talking about broadcast and multicast messages, let's remember that that is at layer 3 of the OSI model. We're talking about IP messaging. So when it comes to TCP and UDP messages, there's no such thing as broadcast and multicast. We're only really talking about unicast. So with that, thank you for viewing, and I hope you found this informative again, and I hope to see you in the next video.